In this video, we'll learn how to test the difference between two proportions or two means using Statcrunch. Let's begin with the first exercise. A group of friends debated whether more men use smartphone than women. So we have two groups, men and women. So I'm going to call the men's group as 1 and women's group as 2. They consulted a research study of smartphone use among adults. The results of the survey indicate that of the 973 men, so now we have N1, which is 973. Randomly says 375 use smartphones, so X1 is 379. And then for women, so these are the men right here, and for women, out of 1,304, so that's N2. Let me just write it properly. So we have N2 equals 1,304, and 404 use smartphone. They're both groups are randomly selected, so that meets the criteria of the test, requirements of the test. Test at the 5% level of significance. So if you assume P1 is the proportion of men and P2 is the proportion of women, you know the null hypothesis always have the equal sign, so you have the equal sign. And you need to test that the proportion of men, P1, is greater than the proportion of women. So this is where the claim is. Now we'll come to Statcrunch and show you how to use Statcrunch. You log into Statcrunch, you open Statcrunch, then you go to Stat. Since this is a proportion test, so you go to Proportion Stats. We have two samples, and with summary, we have summary of the data, and you get this. Number of successes, so I'm gonna get them from the exercise itself. So let me see what we put there. Okay, for sample 1, which is the man, number of successes, we have 379. Number of observations, 973. For the women, we have 404 and 1304. Now scroll down, this is the test. P1 minus P2 equals 0 means P1 equals P2, so it's already done for you. All you have to guys choose is the alternative sign, which is greater than, and then hit calculate. So I'm gonna just scroll down and hit calculate. Actually compute, so let's hit compute, and here you go. We need the test statistic, which is Z equals 3.96. 2 decimal places, so it's a 3.96, and the p-value is so small, it's almost 0, less than, when he doesn't give you a value of the p-value and he says it's less than 0.001 means it is small, so that means it is less than alpha. So this is how you use Statcrunch to perform a proportion test between two proportions. So p-value is less than alpha, which is, so we reject the null hypothesis. And when you reject the null hypothesis and the claim is in the alternative hypothesis, you support the claim and you conclude that there is enough evidence at the 5% level of significance to support the claim that more men use smartphone than women. That concludes the problem. Next question. When you see a question with data about the same people before and after some actions, the two samples are dependent. And when the samples are dependent, you gotta treat it differently. You will have to subtract the two sets and test the difference. So this is when the samples are dependent. Look, it says pre-weight and post-weight of the same student. So that means the samples are dependent. If they are dependent, this is how we deal with the hypothesis test. So before beginning and upon completion of a 4-week exercise program, the weights of 9 students were taken. Use the data given below to test the claim that there is no difference in the pre-weight and the post-weight use a 5% level of significance. So in this case, this is how we perform the test. First of all, you have to create a third column and do the difference right here. We call it D. So 118 minus 123, it's negative 5. 126 minus 135 is negative 5. 134 minus 132 is 2. 162 minus 159 is 3. That's a 7. 188 minus 182 is a 6. 173 minus 170 is a 3. And that's a 125 minus negative 3. And 137 minus 137 is a 0. And this is what you need to test. You need to test the mean of the difference against 0. So when he says there is no difference, that means equal to 0. And that's HO. And for H1, it's going to be mu, opposite sign, which is mu of D not equal to 0. And this is where the claim is. The other cases that you could have in a problem like this, you have equal 0, greater than 0, and H1 or less than 0. But since he says that's the claim that there is no difference means equality. No difference means equal. What's the opposite of equal? Not equal. But the claim happened to be this time in the null hypothesis. Now what we're going to do with this data set, guys, we're going to put it in Statcrunch and show you how to perform the test using Statcrunch. Okay, I put the data in one of the variable var1, and now you go to stat. It's a t-test. So you go to t-stats, one sample, although there were two samples, but when you do the difference, there will become one sample with data. I have no data, not a summary here. And that's my data, variable 1. Okay, we're testing mu of D equals 0 and not equal to 0. So it's already there for us. That's it. That's all you have to do. And just hit compute. Okay, what is the test statistic? Is 0.598. And what's the p-value? Is 0.5661. That's all I need, and I'm done with the Statcrunch. So you just go here and put the test statistic t. That's step number 2, which is 0.598, and p-value. P-value is a huge 0.5661, which is more than alpha. We fail to reject HO. And if you fail to reject HO, here's how you start the conclusion. When you fail to reject HO, we start with there is not enough evidence. At what's the significance level? 5%. Level of significance. We don't have enough evidence to. Since the claim is in the null hypothesis, we use the word reject to reject the claim that there is no difference. And whether pre-weight or post-weight, there is no difference. So there is not enough evidence at the 5% to reject the claim. So we're saying the claim, the null hypothesis could be true here. And that's how you do this exercise when the samples are dependent. Okay, next question. These samples are independent now. To compare customer satisfaction levels of two competing cable television companies, 74 customers of company 1 and 35 customers of company 2 were randomly selected. So you see they're independent. They're two customers from two different companies. And we're asked to rate their cable companies on a 5-point scale, with 1 being the least satisfied and 5 most satisfied. The survey results are summarized in the following table. Test at the 1% level of significance that the data provides sufficient evidence to conclude that company 1 has a higher satisfaction rate than company 2. So HO and H1. These are mean. We're testing the means here. So mu1 is equal to mu2 will always be in the null hypothesis. And since you want to check if mu1 is greater than mu2 here, because it says higher rate, higher average rating. So mu1 is greater than mu2, and that's the claim. Now, Before I use Statcrunch, I want you to notice something very, very important. Look, I gave you sigma 1 here and sigma 2. These are population standard deviation. When you are given the population standard deviation, you must use a z-test. And when you are given S1 and S2, you use a t-test. Since we are given a sigma 1 and sigma 2, it's going to be a 2-sample z-test using Statcrunch. Let me show you how to do that using Statcrunch. So you go to stat, you see z-stats, not t-stats, z-stats. How many samples? 2 samples. I have a summary with summary. And watch. So he wants the mean, which is x1 bar. He gave it to us, is 3.51. Standard deviation of the population, which is 0.5. Sample size was 74. That's for the first company. Second company, the mean was 3.26. Standard deviation was 0.52. And the sample size was 35, I believe. Okay, we need to check if mu1 is bigger than mu2. So you just choose bigger because that's the sign in the alternative. Don't touch the null. There is nothing you can do with the null. Just leave it like this. And hit compute. And here you go, guys. I got z, which is what? 2.37, and the p-value, which is 0.0088. And that's all I need from Statcrunch. I don't need Statcrunch anymore. So I'm going to continue here. Z equals 2.37. P-value is 0.0088, which is of course very small, less than alpha. We reject HO. When you guys reject HO and the claim is in H1, you support the claim. So you're right, there is enough evidence. At the 1%, alpha was 1%, level of significance to support the claim. That or to conclude that company 1 has a higher mean satisfaction rate than does company 2. Okay, you can write this down. So that concludes the third question. I got one more question. A manufacturer claims that the calling range in feet of its 2.4 cordless telephone is greater than that of its leading competitor. You perform a study using 14 randomly selected phones from the manufacturer. So we're going to call the manufacturer 1. So N1 is 14. And 16 randomly selected from the competitor. So N2 is 16. The results from the manufacturer have a sample mean X bar 1, which is 230, with a standard deviation S1. He didn't say population standard deviation, so it's S, 226 feet. And the results from the competitor have a sample mean of 216, with a standard deviation S2 of 32 feet. At alpha equal 5%, can you support the manufacturer claim? Assume population are normally distributed and the population variances are not equal. When he gives you population variances are not equal, that means when you select the pool, you have to put no. And that's a hint for you that it is a t-test, 2-sample t-test, not a z-test. If he says population variances are equal, pooled will be yes. So let me show you how we can do this using Statcrunch. So you go to stat, t-stat, not z, not proportion, t-stat, 2 samples with summary. And sample mean 1 was what, 230, x1 bar. Sample standard deviation was 26, and I had 14 telephones. Sample mean 2 was 216. Sample standard deviation is 32, and I had 16. Okay, see, if he says population variances are not equal, don't select this. But If they are equal, then pooled is yes, you have to select this one. It will be like that, but not in our case here. Okay, what are we testing? We're testing if mu1 is bigger than mu2, just the greater sign, and that's all you have to do, and hit compute. Probably don't see the compute at the bottom. Here you go, compute, and that's all I need. You see the test statistic T is 1.321, and the p-value is 0.0986, and that's all I need from the from Statcrunch. So you come here, T is 1.321, right, if I'm not mistaken, and p-value was 0.0986. What's alpha here? 5%. That's bigger than alpha. So this is the first time we failed to reject HO. Failed to reject HO. Oh no, probably we did fail to reject it in another instant. There is not. Anytime you have a fail, you have to start with there is not enough evidence at the 1% or 5% level of significance to support the claim. Okay, to support. We're not saying we're supporting the claim, we're saying we don't have enough evidence to support the claim. So probably the claim is false. And that concludes the review of the chapter using Statcrunch.